So yesterday we started with relational algebra, and we have seen the basic operations of selection, project, union, intersect, and then minus operation. We have also seen the Cartesian product. Now we will learn about the natural join on the relational algebra. The natural join is a type of a Cartesian product, but it is to join the two tables on the two similar columns, and the entries which are similar will be combined in two tables. So we see the definition of the natural join. So you can see that we are going to join the two tables, which is R and S, and the tuple TR and TS is going to be joined when TR has the same value as T and the TS also has the same value on S. The meaning to say is that we are going to see the common tuples or the common attributes between the R and S. Say for example, in two tables, if the two tables have attribute name ID, then ID of table R and the ID of table S is going to be combined, and both column name which are similar, they are the similar, it is going to combine on the similar column. So it is one of the essential condition that the natural join require the similar column name in the two tables. So look at this example. In this example, we have two tables. And the two tables, look at this is table number 1 and this HOD is table number 2. And you have to do the natural join on two tables. So we have to first see which column names are the same. So you can see that in two tables, the department DPT, this department is the common column name. So it is going to, you can do the natural join in these two tables. So to check whether you can do the natural join on two tables, you have to first see that one of the column name should be same. So now you can go for the natural join because department is same in two tables. Now how will you be combining the rows of two tables? So if you are joining these two tables, after joining, you will be getting up the third table. The third table will be combining the column name of table A and table B. So you have to first see that in the combined table, you will get CID, course, department, and then department, it will not be repeated, and then head. So you can see that in this, we will be getting up the four rows, four columns. So in the four columns, now you have to see which rows will be combined. So you can see that this CS department row will be combined with this CS department row. So first row will be CS01 data base, and this CS department will be combined with CS, and you can get the LX. So look at the first row where we have combined the first row with the first row. And it is going to be combined on the similar entry, which is CS, and you can get the row number 1. Now we will see the mechanical department, ME. So this ME will be combined with this ME, and you can get the row as ME01, mechanical, ME and Maya. So you can see that the rows are combined on the similar entries only. This CS is combined with this CS. Electrical is going to combine with this electrical. So that way you have to combine on the similar column name and on the each and every column name you should be combining only to the similar values. But in case of Cartesian product, what we did, in the case of Cartesian product, we took the first entry and we have combined with all these three. Then we took the second entry, we combined with all these three. Then we took the third entry and combined with all these three. But look at this natural join. In this natural join, we are combining only the similar entries. So finally, you are going to get only the 3 rows. Now we again take the example of natural join. Look at this, R and S. We are going to do the natural join on R and S. First, you have to see which column names are same. So you can see that B and D column names are same in 2 tables. So how it is going to perform the natural join? You can see that how it is going to perform the natural join. It will first calculate the Cartesian product of R and S, and then it will filter, which is a horizontal filter, that is a selection. Out of that selection, it will first find all the entries whose B are same and all the entries whose D are also same. So if you have 2 similar column names in the natural join, you have to check the similarity on both. Now we will see how which columns are going to be there in the resultant table. In the resultant table, you are going to get A, B, C, D and E. BD is not going to be repeated now because we have covered in the previous table. So finally, you are going to get A, B, C, D, E. Now, which rows will come? You have to see the A, B and D, which is 1 and A. So now check here which entries are 1 and A. You can see that this entry is 1 and A and this entry is again 1 and A. So first, this first row is going to be combined with this and this row is going to be combined with this. So it is going to be combined with alpha 1, alpha A, alpha. Alpha 1, alpha A, gamma. Now look at this. 1A is again, one more time it is coming in this table 1. 1A, it is common, so it is going to be combined with this. It is going to be combined with this. So you are going to get this row and this row by using this entry. Now look at which are the other common entries. You can see that 2A is the 2A present. 2A, it is not present in table S. Now we will go for 4 beta, 4B. The 4B is also not present in table S. Now we will go for 2B. We will go for 2B and we can check that 2B is present here. So this row is going to be combined with this and you can get the final row, that is this. So you can see that in a natural join, you can have the selective rows which has the similar entries, which is common in both tables. So you are going to combine on the common field and common entries. So the operations that I again go back to this. You can see the symbol, the natural join symbol is like this. It is a Cartesian product and ended, both of the ends are closed. So this is a natural join. Till now, we have studied the basic operations of union, select, project. They are all called as a basic operations. You can also perform certain aggregate functions over it. As you do in the Excel, you can also do the summation of column. You can do the average of a column. You can find out the maximum of a column. You can find out the minimum of a column. So aggregate functions are also allowed in the relational algebra. And they are the summary of operations, and I explained these operations in detail. Now we go for the questions. So we will first do the question. This question is related to the relational model. In the relational model, we have seen that you can represent the entries in the relational model and we can represent the data in the form of table. Now you have to tell which sentence is incorrect. This question is related to it is related to that which for the attributes you can have the multiple values, but for a row you need to have only a single value. So the first sentence says that, and you have to find out the incorrect one. The first sentence says that an attribute of an entity can have more than one value. It is true. Why it is true? Because uh, uh, an attribute of an entity can have more than one value means if I keep my mobile number, so if mobile number is a field, I can have the multiple mobile numbers. So the mobile number field can have the multiple values. So an attribute can attribute means mobile number which can have more than one value, so it is true. Second is an attribute of an entity can be composite. So it is again a true. The example of this is that you can have a full name that is a composition of first name, middle name, and last name. So it can be the composite entity. You can subdivide into the entities. So it is again a true one. Now look at the third one. It says that in a table, an attribute can have more than one value. It is not possible. In a row, you need to add one attribute should have only one value. You cannot store multiple values in a row for a single attribute. The example is that if I have the multiple mobile number, I have to create the multiple rows. In a single row, I cannot associate the multiple mobile number with me. So that is a wrong sentence. And the third one is in the row of relational table, an attribute can have exactly one value or null value. It is true. You can exactly store the one value or null value is also allowed. Now we will go for question number 2. Today we are doing all the question related to the relational algebra. The question number 2 says, you have been given the three relation employee, that is storing the data of employees. Department, it is storing the data of a department, department name and address. Now you have to, which of the following queries cannot be expressed using the relational algebra operations, which are union, minus, Cartesian product, project, select, and it is row rename operation. So you have to find out which of the which of the query cannot be represented by them. So department address of every employee, you can find out the department address of every employee by by combining the table employee and department. You can combine the two tables on the department name and you can get the address of each employee by using by combining these two, employee and department name. Now next is employee whose name is same as that of department name. You can definitely get, you have to combine these two table and you have to check whether employee.name is equal to department.department name. Then you can check whether they are equal or not. So you can combine the tables and you can have the select or project operation to get the query number 2 as well. Now the sum of all the employees from the salary cannot be calculated by using only these these operators. We need the sum aggregate function to calculate the sum of salaries. So this cannot be performed. It is a correct answer. All the employees of a given department, you can find out, you can display all the employees of a given department from the table employee. So query A, B and D can be calculated by using these basic operations, but sum of all the employee salary cannot be calculated. You need the summation aggregate operation. Now we go for question number 3. The question number 3 says you have two tables which are A and B. Suppose A and B and C and D are two relation schemas. They are two relation schema R1 and R2, and in this schema the B is a foreign key. This B is a foreign key. It is referring to the C. Foreign key always refer to the primary key. So if it is referring to the C is a primary key. So C is a primary key of R2. If the data in R1 and R2 satisfy the referential integrity constraint, the referential integrity constraint I think I should leave now. We will be studying this referential integrity constraint, then we will take this question. Now we will come to the next question. In this question, the three tables have been given, table A, B and C. In this table A, B and C, you have to perform this operation. What is this operation? You have to first perform the union of A, union B, and then you have to do the natural join on C. After doing the natural join on C, you have to apply the condition of AID is greater than 40 or C dot ID is greater than 15. So you have to first do A union B. A union B will give you another table. So first we will go for A union B. Which entries you are going to get for A union B? It is going to get the entries which are present in A or B or both. So you will get 12 this row entry, you will get this row entry, you will get this row entry, then 15 is already covered, so it will not be repeating. You will get 25 row entry, you will get 98 row entries, the 99 is already covered, so it is not going to get. So what will be the result of A union B? Look at this. The result of A union B will be like this: 12, 15, 99, 25 and 98. Now what you have to do, you have to combine this resultant table with C with the natural join. So if you combine this table with the C, look at this C, it has only two IDs which are 10 and 99. And you have to combine this ID with the resultant table and you have to do the natural join, because the two this id of table C is not same as this id of table A. They are not same, all of them are different, so it is same as that of Cartesian product. You have to combine every row of A union B with C. So you have to combine these 5 rows they with you have to combine these 5 rows with this 10 entries and the 5 rows with 99 entries. All the rows will be combined because these ID are not, these both of the IDs are not same. Now you have to, so finally you are going to get you are going to get the 10 entries, these 5 entries combined with 10, these 5 entries combined with 99. So you are going to get the 10 entries. Out of these 10 entries, you have to select only the entries whose AID is less than 40 and AID is greater than 40 and CID is less than 15. So if you apply this condition, AID is greater than 40 and CID is less than 15, you will be getting only these 7 rows. AID greater than 40 and CID less than 15. So all the above entries are CID less than 15 and red entries are AID greater than 40. So finally you are going to get only these 7 rows. First 5 rows are CID less than 15 or AID greater than 40. So finally, out of 10, you are going to get only the 7 rows. So our answer is going to be the 7. You have to calculate the number of rows, which is going to be the 7. So these were the only questions based on the relational algebra. Most of the questions which are asked in the GATE are related to the SQL. So after learning the SQL, then we will be doing the other questions as well. So I am moving to the SQL part now. This SQL is based on the relational algebra only, but it is a human readable language. The concept of all the things are same as that of relational algebra. You can do the horizontal filter, you can do the vertical filter, you can apply the condition, you can do the Cartesian product, you can do the natural join. So aggregate functions, all these are allowed in SQL. So the theory is going to be the same. Data definition language, we have seen the data definition language is the language which allow you to create the tables, which allow you to modify on the structural level. It is not dealing with the data. So if you are creating a table, if you are creating your variables, you have to give them the type of the variable. So here we say them that they are the domains. So yesterday we have seen that every column has a domain. From the domain, they get the values. So the domain can be of character n. Character n is you can have a data type of character and the maximum length can be n. It is a fixed length. Other than the character, you have varchar n. It says that your character can be variable, but the maximum length can be n. You can keep the length which is less than n also. So character is a fixed data type, varchar is a variable data type where the maximum length is n. Then you can have integer data type, you can have small integer data type, you can have the numeric means real data type where p is the total number of digits and d is after decimal how many number of digits are allowed. Look at the example. If you have numeric 3 comma 1, it says that uh, in the right hand side of after the decimal you can have one digit. So you can have 44.5, its size is 3, and after decimal you can have 1. You can also have real, double precision, float n, or many more. Now we will see the data definition language. How can you create the table in SQL? To create a table in the SQL, you have to write a command of create table and the name of a table, which is R. In the name of the table, you have to give the attribute name, which are the column names, and the domain types. A1, D1, comma, A2, D2, comma. So likewise, you can give the way different attributes name, different column names. With each column name, you have to give your type of domain, which we have just studied, that are integer, varchar, or character type. After defining all the column names, you have to define your integrity constraints. In the integrity constraint section, we will be giving the constraint, if any. What are the possible constraints? The possible constraints can be, if I want to say that this age field should always be less than 100. This balance field should always be greater than 0. Or which are your primary keys? They are all integrity constraints. They will be checked whenever you are inserting the data. It will make you sure that your table will never be incorrect. It will make you sure every time whenever you insert the data, integrity constraint is fired. If your data is wrong, the data will not be allowed to insert into your table. So look at this example, create table instructor. it is a table name, instructor, and then you can give the column name as ID, and then its data type, name, its data type, department name, and salary. So you created 4 columns and their domain type, which are a data type. Now we will see the integrity constraints. Integrity constraint has to be defined at the time of create table itself. In the integrity constraints, you can have either not null. Not null means for the sum of the fields you do not want to insert any, you do not want to allow the null entries in any of the fields, then you can give not null. Or you can provide the primary key. The primary key is, we have seen that it is a set of attributes which uniquely identify your table. It is a minimal set of attributes which uniquely identify your every row. And the foreign key is foreign key are the keys which are going to refer to the another relation, and in another relation are the same attributes are going to be the primary key. So it is to reference two tables on the same entries. So primary key and foreign keys both are the integrity constraints. So look at the another example where we have created the table and defined all the attributes. At the time of after defining all the attributes, you can have the integrity constraint. The primary key is ID, and the foreign key is going to be this. So you can have any of them as a foreign key, that is a department name. This department name is going to refer the relation department. In this relation department, the department name is primary key, and it is going to relate the department name of this table with the department name of department. That is a primary foreign key. It is just to establish the relationship between two tables and the relationship between the entries of two tables. So we again see the example of more foreign key. Here we have a student. In the student, the department name references department. It is a foreign key and it is referencing the department table. So this is again the same. We will not repeat it. We are studying the data definition language. All of these the commands are the part of data definition language. Create table is a data definition language. Now you can insert few of the values. You can insert the values by using the command insert into table name, insert into instructor, values. Then you have to use the braces. In the braces, if it is a character or varchar, the value should be should be enclosed in single quote. And if it is a numeric, you can have the direct values, and the sequence of values should be same as that of sequence of creating the attribute name. So this is ID, then it is name, then department name and salary. So sequence is going to be the same and the values will also come in the same sequence. Now if you want to remove all the tuples from the relation, you can use the command delete from student. It is going to delete all the rows from the student. Deleting a row does not mean that table does not exist. You are only removing the data, but the structure of table exists. To remove the structure of table, you have to use the command of drop table R. So it is going to drop a table with all the data. So there is a difference between the delete and drop. Delete is going to delete the data, but drop is going to drop the structure of a table along with all the data. Alter command is used to add the another attribute name. If you have created a table R, now I want to add the another attribute name. So you can use the command alter. alter table R and add attribute name and its domain name. It will alter the structure of a table. This one command, create table student, it is going to create a table student, and in this table you are going to get SID of number 4, surname, date of birth, like this. If you want to add a column name, you have to write alter table student, add column, address and its domain where char 20. So it is going to add the another column. So finally your table will have 4 columns. You can drop this table by using the drop student command. It is going to drop the structure of a table. Now we come to the queries. It is the heart of the SQL, where we can retrieve the data. So query is, you have to retrieve the data, and in the query there are 3 sections. In the first section you have to tell which column has to be retrieved. So the structure is select A1, A2, AN, which column has to be retrieved. The second part is dealing with on which tables you have to do the operation, how many tables, R1, R2, R3, on which table you have to do the operation. And finally, what is the condition? So its syntax is select attributes from table where condition. Condition is always and predicate. Its value is either true or false. The rows for which the predicate is true, only that rows will be retrieved, but the false predicate values row is not going to be retrieved. So meaning to say is that the rows for which the condition is true, they are going to be retrieved, and the false conditions are not going to be retrieved. So we take an example, select name from instructor. From the instructor table, you want to display only the names. So you have to use select name from instructor. We have seen that the select operator in the relational table, that it is only a horizontal filter. It is only a horizontal filter. But in case of this, if you are giving only the attribute name, means you did the vertical filter. You want to get only the name as a column in output from the instructor table. The select also allow you to use a keyword that is a distinct. The distinct, as the meaning says, you want to display only the distinct department name. You do not want to get the repetitive entries of a department. So if you want to get one entry, one display for one entry, then you can use the keyword distinct. Select distinct department name from instructor. It is going to give you the distinct department name from the instructor. If you do not want to remove the duplicates, you can write select all department name. So it is not going to remove your duplicates. CS department will come for multiple number of times if there are the entries of CS multiple number of times. So if you want to display all the columns irrespective of attributes, you can use the star. You can use the star. Select star from instructor. So it is going to display all the attributes from the instructor. In this select command, you have to give the attributes. Along with the attributes, you can directly use the expression. In the expression, you can use plus, minus, star or division. Say for example, you would like to display ID, name and salary divided by 12. So automatically you will get 3 attributes and salary is going to be divided by 12. Please note that it is only a display. You are not going to change the table. So finally, whatever you are displaying, your display salary will be divided by 12, but original salary is going to be intact. It is only a display. We are not changing the table. With the expression also, you can rename an attribute. For renaming an attribute, you have to use a as clause salary by 12 as monthly salary. So your column is going to be renamed as monthly salary. In final table, you will receive the columns as ID, name and monthly salary. Now we come to the conditional retrieval. In the conditional retrieval, you have to use the where clause. In the where clause, you have to give the condition, and that condition is a predicate which is going to be either true or false. In this command, we wish to display all the names of an instructor whose department name is computer science. So select name from table instructor where department name is equal to single quote computer science. In the where clause, you can do the AND operation or operation, any logical operations are allowed. If you want to combine the two conditions together, you can use AND operation. I want to display all the names whose department name is computer science and salary is greater than 80,000. So condition will be attribute name, department name is computer science and salary is greater than 80,000. So you can do any arithmetic operations along with the logical operations and you can get the predicate. In the from clause, you have to give the table names. So, every query cannot be solved by using only a single table. You may have to retrieve the data after combining the tables. What are the ways to combine the tables? We have seen that you can combine the table by using the Cartesian product or natural join. So from clause allow you to do the Cartesian product. How to do the Cartesian product? You have to use the comma and two tables. Table 1, comma table 2, automatically it do the Cartesian product between these two tables. And out of these two tables, it is going to create a single table after Cartesian product. And then you have to do the where clause and select clause. So the first computation which perform in the select from where, first it will perform the from clause and it will find out its resultant. After finding out its resultant, you have to apply the where clause and then it will display the select clause. So sequence number 1 is from, sequence number 2 is where, and then sequence number 3 is select. So that way you can check, you can do, say for example, I would like to do display all the entries by doing the Cartesian product between the instructor and teacher. So select star from instructor comma teaches. It Cartesian product and display all the entries. So look at this instructor. This is teaches. You can do the Cartesian product instructor comma teaches. Every row is going to be combined with every row in teaches. So you are going to have these multiple rows. Second row is going to combine with all the rows of teaches. So that way you can have the many rows and then you have to display star. In the star you can see that this ID is same. So it is prefixed by institute and this ID is prefixed by teaches. And the rest of the IDs are unique, so they do not need to be prefixed by table name. Now we will see how can you perform the where clause. In the where clause, you can use the select and from clause we have seen. Now you can use the where clause. In the where clause, you have to compare instructor.iz is equal to teachers.id. So you have to display only the rows whose instructor.id is same as teachers.id. So that way you can do the multiple conditions, you can do the multiple comparisons. So likewise here they want to check the similarity, as well as they want to display only the art department. So you can do as per the query asked. Now we will come to the rename operation. The rename operation is allowed. You can do the rename operation in select clause. You can do the rename operation in from clause as well. Rename select clause, we have seen that salary divide by 12 renamed as monthly salary. So you can do in the select clause. Here in this example, we are doing the renaming in the from clause. We have seen that we want whenever, why do we want to rename a table? Because we want to perform the operation of a table with itself. If I want to perform the table of instructor with instructor, then one time I am going to rename it as T and the another time I am going to rename it as S. Now you have to use these two tables as T and S within that query, and then you can do the various operations like this. So if select distinct T dot name instructor as T, comma instructor as S. T dot salary is greater than S dot salary and S dot department is equal to computer science. What this query is doing? This query is giving you all the instructor whose salary is higher than some of the instructor in computer science. So it is going to display all the instructor whose salary is greater than some of the instructor in computer science. In this example, we are going to compare the salary with the salary itself in the same table. That's why we need to rename it as T and S. Now we will come to the string operations. In the string operations, as we do in the C language, you can do the string concatenation or string retrieval. Here we are only retrieving the data, so we can perform the string operations in the from clause. In the from clause, we can use the string operations and you can use the wildcard characters. The wildcard characters are for generalized matching. So you can individually match the character or you can match the set of characters. So you have to use the wildcard characters. To compare the string, you have to use a keyword like for the string comparison, and you can use the percentage as a wildcard character that matches any substring. And to compare only a single character, you can use the underscore. It is going to match only a single character. So substring matching require you to use the percentage, and underscore will do character by character for you. So you can see the example. Select name from instructor where name like percentage means any number of characters and any character can come here. After that you should have the word DAR, and after DAR you can have any string. So it is going to give you all the names. In the name, substring is like DAR. So it is giving whether it can start with DAR, whether it can end with DAR, whether in between it can be a DAR. If substring is DAR, it is going to give you all the names. Now we will see the escape characters. Escape character is require you to consider the wildcard character as a character. Otherwise, wildcard character is used as a formula. But if I want to use the wildcard character as a character, you have to use the escape mark. If I want to check 100% as a string. So percentage is to be treated as a character. It has to be prefixed with escape. So in the string matching operation, all the patterns are case sensitive. You can use the percentage and underscore for the substring or the character matching. SQL also support you to the string operations of concatenation, conversion, and you can find the string length as well. We have seen that in the relational table, the order does not matter to us. Only the member or the tuple matter to us. If you want to display the data and you want to order them by any order, you have to use the clause of order by. For the retrieval of a data in any order, you have to use the order by clause. Select distinct name from instructor order by name. It is going to display your name in ascending order, order by name. So the ascending order is a default order. If you want that your name should be the descending, you have to use the keyword as DESC. Ascending is a default, but descending has to be specified. In the where clause, you can also use the between operator. The between operator says that if you want to check the range of a data, if you want to check the salary between $90,000 to $1 lakh, so you have to use a range, you have to use a duration. Such type of things between can be used in case of value comparison, in case of time comparison, or any duration date comparison. That way you have to use the between. Here you would like to display all the names of an instructor whose salary is between 90,000 and 1 lakh. So that is it for today. We will continue in the next class. So in the tomorrow's class, we will be doing the questions of the gate on the SQL, and we can continue. Uh, we can continue for the later half or later chapters. If you have any queries, please write me to latesh.gagan@gmail.com. I can answer you your I can answer you your queries. I can answer, or you can give me the feedback. If you want to have any change in the teaching, uh, or any additional content has to be covered, you can just write me on latesh.gagan@gmail.com. So thank you all for joining. We'll see you in the next class.